Hello everyone, today we are going to solve a two problem. First is longest increasing subsequence and second is Russian doll envelope. These both problem are very similar, but first of all we can solve the longest increasing subsequence, and if we solve this problem then the Russian doll envelope is very easy for us. So first of all we can see the problem. So in this problem we have given an array and we have to return the maximum length of longest increasing subsequence. So what is longest increasing subsequence? It is that you have to find the subsequence which is increasing order, like here we can say 2, 3, 7 and 101. It is the longest increasing subsequence, LIS. So basically it is the longest LIS and we return the length 4. We have multiple approaches to solve this problem, but first of all we can see the basic approach, which is recursion. Then we will go for dynamic programming, and at the end we can show the most optimal approach. So let's take an example. Suppose we have this array and we have to find here in this array longest increasing subsequence, that is LIS. So what is basic approach? If we solve this problem by recursively, what we can do, we can choose the first element from here. So if we choose the first element from here, so we will work at this portion, and what will we do here, we will be choose that particular element which is greater than 0, because we have to find the longest increasing subsequence. So in this array we can choose only those elements which is greater than 0. So 1 is greater than 0, yes, it is correct, so we would consider it 1. Can we say 0 is greater than? No. Can we say 3 is greater than? So we can say yes, it is greater than. And can we say 2 is greater than? Yes, 2 is also greater than, and this 3 is also greater than. So if we choose one element, if we choose this element here, so we can work at this portion. So in this subarray we can find which element is greater than 1. Can 0 is greater than 1? No. So we move forward. Can 3 is greater than 1? Yeah. So we can consider 3. Can 2 is greater than? Yes, it is greater than. Can this 3 is greater than? Yes, this 3 is greater than. And if we choose this 3, basically if we choose here this 3, we would be work at this portion, and we cannot find any element which is greater than 3. So we backtrack from here. Then we select this 2, and we would call here at this portion, and we can see 3 is greater than 2, so we would consider that 3. And then we backtrack from here, we would see 3, so there is no subsequence, so there is no more call. We backtrack from here, we would go here and here. So at the end our longest subsequence would be this one. It would be our longest increasing subsequence, which would be 0, 1, 2, 3. And we can also call here, like if we choose 0 here, we can also choose 1 from initially here, and then we would say 0 initially from here, 3 would be initially here. So we make each and every call, but you see there is an overlapping in this call, where this one we can solve. So too we already solved this portion, and again we solve this portion again, so this is an overlapping. So to avoid overlapping, we will do memorization, and after that we will do dynamic programming. So I will show you the memorization code, and I hope you will do dynamic programming by yourself, and at the end we will see the more optimal code, which will be more optimal than this dynamic programming code. But first of all we can see the memorization code, how it will work. I hope you understand the basic call of recursion, how it will be work. It will select the first element and then call from rest of the element, basically +1. If I is here, so we will call I +1 would be there. Okay, so I hope you understand how the recursion code will be work, and then we store the each and every data in the memorization array, which would be initialized by default -1. So I basically show you the code, then we will see the more optimal code. So it would be our basically code. We have get an array and we have to find the basically maximum longest increasing subsequence. So basically we make an memorization array by default, and then we can fill this array by -1, and then we can call another function which would be, we can say, our helper function. So in the helper function, this is our array and this is our target basically from at which index particularly we are, and this current basically store the current element. Like if we here, so current would be 1, if we here current would be 0, so this would be store this, and this is our basically memorization. So what if target is equal to the nums length, means if target is equal to here index out of bound, so basically we directly return 0 from here. It is our base condition. And if we already store the element, we directly return here, we cannot call from further here. So we can choose, we can make a for loop, and if our nums I, if our basically this we can call here, and if this element is greater than our current element. What would be the current element? Initially we have passed the minimum value, because initially we have choose any element which would be present. So if it is greater than, then we can call +1. Why +1? Because if we choose this element, we can say we can consider 1 length, so we call 1 here, and we can call nums I. Why would be I? Because it would be considered as that we already work at this case here, and we would be initialize nums I, and we can pass the memo. And if our answer would be greater than, if our this answer would be greater than this one, so we can reinitialize this and we set our memorization array, and we directly return from answer here. I hope you understand this code. But now we will understand more optimal way to solve this code. Now we have to apply binary search here. How binary search will work? Let's see. Let's see, we have the same array which would be by default 0, 1, and it would be 0, 3, 2, 3. So what we can do, we make an same size of array. So we make same size of array. Okay, so if this size is n, this size also be n. Why? Because in this array we will store the element in the sorted way. Like the element would be 0, 1, 3, or we can say 0, 1, 2, 3. So in this array we can store the element in a sorted way. And how this will work, I will tell you. So first of all, why we make this element to the n size? Because if all the element are here is sorted side in a sorted way, like 1, 2, 3, 4, 5, 6, so we have to store all the element in this array. So that's why we take this array would be n size. Okay, so let's try to understand how it will be work. So our array would be this one. So we have take the similar array here, and by default all the value would be 0. Okay, so basically we can make a for loop from at this index to this index. So initially we are here, and we have to find the best position to insert in this array so that the array would be sorted. Okay, I will tell you how we can apply logic here. Basically we can apply the binary search here, simple binary search, in which we can pass a function like our array would be there, this array, and our starting position our ending position and the element. What is t? T basically element, like here we have 0, so we can pass 0. So this binary function will return an index, and this index will tell what is the correct position to insert this element. So I will tell you how it will work, but let's suppose it will return an index 0, like 0, 1, 2, 3, 4, 5. So what is the correct position for 0? It would be 0. If 1 is come, what is the correct position to insert? It would be 1 here. Again, if 0 is coming, what is correct position? It would be this. Okay. And if 3 is coming, what would be the correct position? It would be 3. And if 2 is come, what would be the correct position? It would be 2 here. We can rewrite here. And if 3 is coming, what would be the correct position? It would be this. So this is the way to store the element. And binary function work in a log n time. Log n time. Okay. So we can say we do this code in n log n time. Why n log n? Because it's take the n time, and this function basically take log n time. But now we will see how this insertion would be work. Let's say it. So now we see how insertion would be work. So let's suppose we make an array. So we make this an array with the same size, and initially our start would be 0. This would be a start, and our end would be 0. And we can make an variable which is max, and what it will be denote? It will be denote the maximum length of subsequence till now. So we can say, and max also denote the end position. It will denote the end position, and it will also denote the longest subsequence till now. Okay. So initially both are 0. So we have a function, like in this function we can pass this array. So we can pass this array and our starting position, which would be 0, always 0, and our end position, which would be max, and the element. Let's suppose we have passed the element in the t. So what would be the t? T would be the this. So how the binary function would work? We can find the, first of all, we can search the while loop, and while loop would be start is always less than end, and then we find the mid element, and in the mid element what we see, in the mid element basically we start plus end divided by 2, and if mid is equal to array of mid basically is equal to the t, so we directly return mid, because if the element would be same, so like if we have 0 here and we get another 0, and if we get mid would be here, so it would be the correct position, because so that's why we return mid. Okay, so mid would be the correct position. Else what we can do, else if our array of mid is greater than t, that means if we find mid element here and it is greater than t, so we would work at this position. Okay, so our end would be mid, and else if mid is smaller than that, so our starting position would be mid plus 1. It would be simple. Okay, and at the end we will return start. Why we can return start? Because suppose that if you have this element, suppose that if AND would be here and start would be here, and if your start would pass the AND, suppose if start would come here, so basically this condition will be false, and we can say start is the correct position to insert the present element, so we directly return start here. Otherwise we would return mid. If we already get the element which is already here, so we return mid, otherwise we will restart, we return start. And if we return start, so it would be correct position to insert that element. Okay, I hope you understand this concept. Let's see. So initially our start would be here and our end would be here, so we would see 0 is coming, so our start is not less than end, so it directly return start here from here. And if our basically in our function, in our another function, we can say, we can call the int index, and in the index we can make for binary search, and this would be our binary search. And if our index basically equal to the max, then we would increment the max function. Why would do? Basically because if our max would be here, suppose that if our max would be here and we got the same index, that means we have add an element here, so we can say our max would be increasing. Suppose we have two element here and our AND would be here, or we can say our max would be here, and if we get the index 0, like if we insert 0 here, okay, and then 1 would be here, and again we would get the 0, so what we can say, our index would become here 1, so it would be return 1. This is the correct position for 0, but it is not equal to the max. That means if our max equal to that element, if our basically if we got the index which is equal to this position, then we can say our longest subsequence would be increasing. Otherwise we can't say it would be increasing. Let's try to understand again. Basically first of all, if we see the 0, it would be correct position here 0, and initially our max would be basically, first of all give the index 0 1 2 3 4 5, okay. So if 0 would be there, so initially start would be here, and we can say it would be written the correct index would be 0, so we insert 0 here, and index would be equal to the max, because by default our max would be 0, so we can increment one max here, so our max would be here. And if we have got the another element 1, okay, and if this position equal to that position, then we can say we can go to the longest subsequence element, then we can increment this element. So the position would be, we return the start from here 1, so we go to this element 1, and then we can increment this, okay. So our max would be basically 2, okay, so max move here, and if we move at this 0, we can find that the correct position would be 1, okay, but it is not equal to max. We can say when the element at this block, then we could say we can increment our maximum variable, because we would at the end we would return the max variable, and it is our longest common subsequence, and we would increment only if we add the element at the current block, okay. So that's why this condition it is very important. I hope you understand. So the code of this problem is here. It is very simple as well. Like we can check the index from here. It would be 0 by default starting, and then max, and then nums I, or we can reinitialize here, and if our index equal to max, so we can increment this, and this is a binary search function, simple, and at the end we return maximum variable, and it is very optimal code. You can see it is run in a big of n time, n log n, sorry. You can see here it is very fast code. Now we have to move the similar code. It is very similar. Now it is very easy for you to understand. It is Russell don't envelope. Okay, so in this question what you have given a 2D array. Okay, so in the 2D array basically you have given like 2D array like this, 5 4, then 4 2, then 3 2, then 3 1. Okay, so what you have written the maximum envelope in which you can insert the envelope by itself. Like this would represent the width of envelope, like this is the width of envelope, and this basically represent the height of envelope. Let's say it is 3. Okay, so it is height of envelope. Similarly, this is another envelope which width is 4 and 2, and you have to insert the envelope within envelope, and the condition is you can insert the only envelope whose you can insert this envelope to this envelope only if this width is smaller than this width and this height is smaller than this height. Okay, you cannot insert this envelope in this envelope. Why? Because its width is smaller than this width, but its height is not smaller than this width, so you can't store this, and you have to return the maximum envelope which you can store. So its answer would be 3. How 3? Because you insert this envelope in this envelope, like you insert this envelope into this envelope, so and this envelope into this. So basically it's look like this. This is our greater envelope, then this is this envelope, then this is this. So you can insert the maximum 3 envelope. Okay, so what is the right way to solve this? We can do the same approach, follow here. First of all, what we can do, let's suppose we have given an envelope like this, like 5 4, okay, and 6 4 would be there, 6 7 would be there, and 2 3 would be there. So what we do, we can sort this array on the basis of width. Okay, on the basis of width. So what we get the 2 3, okay, then we get the 5 4, then we get the 6 4, and then we get the 6 7. Okay, so we can say this envelope is in the form of increasing order. Okay, because it is the smallest envelope, then this envelope would be there, then this envelope would be there. So we can work only at the height, like 3 4 4 7. Okay, we would only work at here, but the problem here is if you find the longest subsequence at here, okay, if you find the longest subsequence at here, you would find that the correct answer would be 3 4 and 7. Okay, like you would place this envelope into this and this envelope into this. This would be correct, but what happen if you choose element like this, like you have to choose this element, then this element, then this element. This would be correct by your logic, but it is not correct. Why? Because the height of both the width of both envelope would be same. Okay, so we cannot choose this element. For suppose you have given an envelope 6 4 or 6 7, okay, and So what you can do, you can just sort this array on the basis of width, so you can get the same array. Okay, and then you will find the longest subsequence on the basis of width, on the basis of height. So you find that 4 7 would be the longest subsequence, so the answer would be 2, but 2 is not correct. Why? Because the width of both the envelope would be same, and if both the height or width would be same, then we cannot consider that envelope. So what would we do if we get the basically same width? If we get the same width, then we would sort the that element on the basis of their height in decreasing order. Like our envelope would be 5 4 and 6 4 6 7 2 3. So we would sort on the basis of width. So 2 3 will come first, 2 3 will be here, then 5 4 will become 5 4 would be here. Then we got the two element which having the same width. So what will we do? We will be short on the basis of height, and we will kept those element whose height is in increasing order. So we put here that element 6 7, then 6 4. Okay, and then after that we would find the longest subsequence on the basis of height, like 3 4 7 4. Now we can apply the same logic which we apply in the LIS, which is we can do in n log n time. We can sort the array in n log n time, and then we can apply the binary search in log n time. So our effective time complexity would be n log n. And what is correct answer from here? It would be 3 4 7. And we never get the element like 3 7 4. That's why if the width is same, then we sort the element on the basis of height, and we kept the height which is in increasing order. So this is very easiest question if you understand the LIS. I hope you understand this question.